right, so the other most common resampling procedure is what we call bootstrap sampling. And the idea with bootstrap sampling is what we're actually doing is we're going to sample certain observations, but we sample with replacement. And that's kind of the key word that differentiates bootstrap sampling from k-fold cross-validation. So say we have this example data right here, where we have however many different observations. In this case, we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 total observations. What we do is we create different bootstrap samples, and each time we're going to sample observation, put it into our bootstrap sample, but we put that observation back, right? And so what you'll see is we will always have a fairly similar distribution of the observations in our original data. However, in some cases, we may have certain observations sampled more times or less times than what we see in the original data. For example, here we have 3 observations that are in this blue. For the first bootstrap sample, we only have 2. In the second one, we have 3. In this one over here, we actually have 4, right? And that's because we sample an observation and we can put that observation back in to be resampled again, right? So that's the difference, is that we'll actually have observations that can be represented more times than one in a given bootstrap sample. So what we do is we'll sample with replacement, and all of those observations that we sample from our original data, that's what we'll use to analyze our data on, or basically we'll use that to train our model on. And then for any of those observations that were not sampled from the original data, that's what we end up calling an out-of-bag sample, right? Those are all the observations not included in the bootstrap sample, and those are the observations that we'll actually test our model's performance on. And so we just do this process however many times. Typically, again, 5 or 10 times is very common. Now, this idea of sampling with replacement, what you'll actually find is that on average, about 63.21% of the training set is going to be contained at least once in the bootstrap sample, right? So that means out of all our observations, if we have 100 observations, we can assume roughly 63 of them will be included in our bootstrap sample. And that means there's going to be about 37 that are not included in our observation that we can then use as our validation set. Now, what does this look like? Well, here's an example data set here. It's got 32 observations. We see each observation listed along the x-axis. And in this case, we did 10 bootstrap samples. And so you can see all those where it's just white for those observations, they were never sampled. Those are going to be the observations that we put in the outer bag and that we'll actually use to validate our model on. However, all the other observations, we can see that some of them are sampled 1 time, some of them are sampled twice, some are sampled all the way up to 4, even 5 times for that given bootstrap. So if we looked at here bootstrap 10 and we looked at observation 26, that one, it looks like it was sampled either 4 or 5 times. So it's actually, that given observation is represented in that bootstrap sample 4 or 5 times, just because we are sampling with replacement. All right, so how do we actually apply bootstrap sampling? Well, it's a very similar process that we saw with k-fold cross-validation. However, the main difference here is we create a bootstrap sample using this bootstraps. Again, we supplied our training data. We tell it how many bootstrap samples we want to create, this time 10. And we can stratify on our response variable of interest if we wanted to. And then we have the exact same process that we did before. All here, the only difference here is down at fit resamples. We now pass it our bootstrap samples object that we created up here.